Richo here from DA Australia. Welcome back. Check this baby out. How cool is this scheme? This thing's pretty awesome. It's a new 3-metre Sukhoi from Comp-ARF, the SU-31. It's been out for a little while now. This is one we just put together for a bit of a shop hack to get around on. It's got a DA-200 and some nice components. What we'll do is we'll take components off of this and we'll show you around it, see what it looks like. We'll take the engine, show you through the engine bay and a few other areas that we've done a few changes just to try and get the thing to perform a little better. So what I'll do is I'll call Mark over shortly and we'll start pulling it apart and you can have a good look at it. Now we've got the thing pulled down, what we'll do is we'll get Mark to come over and we'll show you through the unit. As I said, this is running a DA-200. We're running high voltage Futaba servos throughout, and you'll notice it's got a power box competition in it. Running Franco 5200 lithium ions, and probably the first thing you'll notice is it's got 2 fuel tanks. Now running a 200 on this one, we decided we'd try 2 separate tanks, one for each carburetor, and it helps a little bit with the state of tune. You can sort of tell that they're drawing fuel quite equally and also increases the capacity. You'll see with this competition it's an SRS version which will run 2 3-channel S-bus Futaba receivers. Just because they're 3-channel doesn't mean that's all they'll cope with. Being S-bus, they'll cope with as many channels as your transmitter puts out. This gives it a redundancy system. If one receiver drops out or fails, the system will automatically just jump onto the other receiver and you won't even know until you look at the readout. Further down you'll see the SWB self-adjust tray. As I said, we're only running 2 BLS 157 HV servos on these. These are 37 kilos each. They're very powerful. We didn't use the composite ARF tray that they supplied. We sort of made up some brackets here to put these down here. These are all balsa and light ply, all quite strong, all got a nice big surface area. Further up inside you'll see mostly right up through the inside there, the ignition trays right up at the front, and a power box spark switch. So pretty much else, there's not much else in there besides the canister system. We're running a 2-in-1 system with KS95 rear exits on this, and the other thing you'll notice is it's got a power box magnetic sensor switch. So to turn the item on you just use a small magnet, the power box supply over the outside, that's it, airplane's on. Cool little system. You'll also notice on top of the fuselage here we're running 2 vents which are facing forward to scoop air in, to blow some nice cool air down over the top of the system to keep everything nice and cool. There is also some alloy louvers down the bottom here working in the normal direction to suck the air out. There's 2 that have been added here and 2 on each side of the servo tray. This helps get all the heat out of the cabin, and a little bit of forced air at the top just assists it in doing that. Okay, at the pointy end of the machine you'll notice, as I said, we're running a DA-200. This is a lightweight cylinder version. It's got the aluminium crankcases and the cylinder's been light. Now this is 500 grams lighter than a standard DA-200. You'll notice the baffling here, none of this is standard. This is stuff that we've made up ourselves. This is all made of 1mm alloy and been bent to suit. Effectively all the air going in is all captured here and forced down through the cylinders, then exits out from the bottom of the cowl. One thing you might notice here is we use stainless steel button screws rather than the standard just black Allen headed ones, and with some Jubro nylon washers. Those little nylon washers stop taking the paint off and they add a little bit of friction, kind of like a nylock nut, stop them coming out. Alright, first thing you'll see is the baffle box here. This is what I was saying with the baffling on the 200. You want to force all the air down in through the cylinders. Any air going in through the cowl goes in through the front here and nowhere else. So it can only go down in through the cylinders. As I said, it's made of 1mm alloy and some balsa for shape. And generally I just try to scoop it all down so we get enough air over the rear cylinders. Now up on the ignitions here, these are resting on some nice Seacraft mounts. You'll also notice up here, this is the LED for the kill switch. I've just got it on an extension lead here so I can get it up near the front, and when I'm sitting at the front of the plane I can see when either the ignition's on or off when I'm flipping the thing, which is pretty important. You want to make sure you keep your digits on your hand. Okay, is it your DA-200? As I said, everything's baffled quite heavily, everything going in, down through the cylinders. We're running an SWB offset mount, 3.5 degrees on this model. And as I said, you can see both the ignitions, both the sensors at the front there, running up to the ignitions here. And as I said, both of these are operated with one kill switch and one battery. Okay, so here's the cowl off the whole engine. As you can see, 200. It's running 2-in-1s. These were, I made these ones up myself, these 2-in-1s, but you can buy production versions now. KS make them, MTW also make them. Makes life a lot easier. We've experimented with different types of headers. 2-in-1s, reasonably short, with these KS95 cans, work really well. We're getting really good RPM out of these, really good throttle transition. It's a pretty simple setup. You'll also see here we have two separate fuel systems. One for each carburetor. This helps a little bit with the stator tune to help to keep the tune, make sure you get the same sort of fuel draw for each carburetor. Four cylinders can be a little more complex as far as the tune goes, but once you get them right, they're pretty easy. Here's a linky system away from the throttle. You'll notice that this is a little different to standard. I've dropped another arm further down to get this away from the engine mounting bolt. You'll also notice this is a flexible rod, so it's pulling to work both carburetors, and transfers no vibration back to the throttle servo at all, and there'll be no wear and tear on your throttle servo or carburetor arms. Right, on the wing of the Sukhoi, Comp-ARF have moved away from their top hinge skin, hinge skin system, whereas the whole aileron is part of the wing. Now it's all separate. There's one pin that goes down right through the centre of it to hold the aileron on. As you can see, it's got two servos, one in the inner bay and one in the outer bay. All of these have got ball links and turnbuckles on them, which we've added onto them, and dual control horns. It's a big surface. You want to make sure you've got pretty powerful servos on these. As I said, we've got 37 kilo high voltage servos on these, and they work really, really well. And when you get down the other end, that's where the hinge pin comes through. We've just brought it straight through the hole here and added an R-clip to hold it in place. This little item here is a Seacraft item, really nice for holding your leads in place. It stops them rattling around inside. And you'll notice I've got a piece of heat shrink over one, just to differentiate between the two servo leads. You don't want to mix them up. You'll get a lot of binding. You can add little numbers on here like I did just to know what's going on, but pretty much these will rub off after a while. I find heat shrink's the easiest. Small piece of heat shrink, you know exactly where you're going. Lots of carbon around here on the wing root just to make the thing nice and easy. And if you can see down inside there, all the leads are nicely clipped in and held in place. Stops them rattling around, chafing and wearing out. Okay, with the elevators, we've got a fairly big slot here, but what I've done is in the manual they like to have the servo shaft closer to the trailing edge. The problem we find with this is on the downward side of it, if the shaft's further this side, it snags up really badly on the linky snags up really badly on here at the trailing edge. So we flip the servo over the other way. It means you run a slightly longer push rod, but you can run shorter arms and the whole lot can disappear inside the stab. Nice ball links, dual control horns. Again, centre pin hinge right through the centre of the thing. And if we flip this over, you see that's how we're holding the pin in place. And again, down inside, lots of clips to hold the leads in place, stop them from all rattling around, rubbing on carbon and wearing themselves out. One of the things I do like to do on my composite planes is holding the T-nuts. In general, in the manual, I'll tell you the T-nut round and reverse with the spiky bit sticking out and just glued onto the edge of there. It looks kind of untidy, a little messy. Here I make little ply donuts, little rings, and just punch in the T-nut in the ring, then glue the whole lot down. It looks neater. It gives a little bit more surface area and you're not sticking metal with glue. It works kind of nice. It's nice and neat. Takes a little longer, but it does look really neat. You'll also notice all the vents have been cut open on this to vacate the air out of this. We've done this in the top and the bottom of the cowl, and it does aid a lot in getting the air out. These vents work really, really well. They create a low pressure system here facing all the air out, and they draw a lot of air out. It works really well. Okay, at the back end of the plane we have a J&J carbon tail wheel. It's a direct drive one, which I've changed a little. I've used a spring system with a 3mm screw going into the back of the rudder. That does all the steering. It steers quite well like that, works really good, quite happy with that system. Not so much rubbish at the back there going up to different horns. Whatever way you like to do it, I kind of prefer this. We have the Seacraft wire tensioners and wire keepers at the back here. Finishes it off nice and neat. As you'll see, we have grommets all through it and clips to hold our leads. It's imperative that you put the grommets through here when you're running leads through fiberglass. It'll cut through it quite quickly. These are easy to get. You can get any of those from any of your rubber suppliers. They're quite easy to come by, Clark Rubber, etc. If you look underneath the aircraft, we have this is our fuel vent lines. I run them up to the rear here, keeps the mess down. These are Hanger 9 product, nice and neat, quite effective, easy to use. And again, you can see all the louvers at the bottom here to exit the air out. These are the exits for our canisters. These are rear exit KS95s. Again, keeps things nice and tidy whenever the exit's near the rear. I get asked lots of questions about how I hold the hinge pins in. You'll see down here I've got a plastic plug here. This is an automotive part I picked up from any of the automotive stores you can get. It's a body panel clip. It's quite easy to come by. It's for holding the interior panels in your car in. Nice and effective. It's got a 4mm shaft in it. It just pushes in from the bottom, holds the pin in place. At the top end, because it was slightly narrow at the top here, this is a gardening reticulation component for like your Pope gardening systems. It's just a plug to plug any kind of holes. You've got this 4mm, pushes in through the hole. Looks kind of neat. Alright, that was just a quick overview of this particular aircraft. If you've got any questions, shoot us an email. We'll try and help you out. Anything you want to know a little bit more about, let us know.
Yeah.
The floor's a bit dirty.
Righto, when you're ready.
Ready?
Yep.